minus, what about 100 by 32? What I'm going to have there should be 3,200. Okay? And what are we having? If you are having this 4,000, okay, 4,800 minus 3,200, we are going to have 1,006. Okay? Which is 180 theta. So from here now, we are going to have theta degrees Celsius will now be equal to 1,600 divided by 180. And if you try to get that value straight away, 16,000 as 1,600 divided by 180, what we are going to have will be 8.888. Let's say 8.89 degrees Celsius. And that will be the value. 8.89 degrees Celsius. The next question says, the melting point of naphthalene is 78 degrees Celsius. What is the temperature in Kelvin? Yes. To calculate in Kelvin, it's going to be any value in degrees Celsius plus 273. Any value in degrees Celsius plus 273 will give us in Kelvin. So the question says, we are given the particular value, the melting point of naphthalene is 78 degrees Celsius. What is the temperature in Kelvin? In Kelvin, it's going to be, there is 78 degrees Celsius plus 273. Whatever the answer give us will be equal to the value. 78 plus 273 will be equal to 351 Kelvin. That's what you are looking for. Just add 273 to anything you are given in Celsius. That one will give you in Kelvin. 78 plus 273. And that's that. Let's quickly consider another question right there. Another question says, calculate the length which corresponds to a temperature of 20 degrees Celsius if the highs and steam points of an ungraduated thermometer are 400 millimeters apart. Let's take it like this. We are going to compare this time around. For a Celsius scale, we have 0 degrees Celsius and then 100 degrees Celsius. This is for steam points, this is about ice points. Then we are not having another value. We are given a value here above the steam, above the ice points. Above the ice points, we are given 20 degrees Celsius. We are looking for another value that will correspond to this in millimeter. If you look at that question, it said if the height and steam point of an ungraduated thermometer are 400 millimeters apart, which means this is 0 millimeter for the steam for the highest point, this is 400 millimeter for the steam points. So what are you going to use? You are still going to use the same formula given to you the other time. We are going to have L theta minus L naught, L100 minus L naught is equal to X theta minus X naught, X100 minus X naught. Okay? Your L theta, you are using this value for degrees Celsius, the other value for this. Okay? L theta is the value above the highest point, which is 20 minus 0, 100 minus 0 is equal to, this value is the value we are looking for here. which is, put it as theta, minus x naught, which is 0. Then we are having 400, 0 again. This is 20 over 100 is equal to, this is theta over 400. Because this minus 0 is still this minus 0 is still this. Cross multiply. 100 theta is equal to 20 times 400 theta 20 400 divided by what? 100. If this cancel this, we are having 20 times 4. That's what we are having. And 20 times 4 will give us 80 millimeter. That means the value we are having here should be 80 millimeter. That will corresponds to 20 degree what? Celsius. And that is simple calculation for that. The last question says the height of the mercury thread in a mercury in glass thermometer when in melting ice and then in steam are 3 centimeter and 18 centimeter respectively. Let's take it one by one. We are given the reference point of a particular thermometer. We are given the melting point and we are given the melting point, the highest point. Then we are also given the boiling point. Okay? So let's take it one by one. For our highest point is 3 centimeter in that question. Then we are given 18 centimeter. They now said at what temperature of 60 degree. Let's take another to compare 60 degree. Okay, what will be the value of this in millimeter, in centimeter rather? Okay, for this one is 0 degrees Celsius. This is 100 degrees Celsius. We are still going to make use of the same formula given to you. L theta minus L naught, L100 minus L naught will be equal to x theta minus x naught, x100 minus x naught. We are going to use this one for this. We are going to use this one for this. Okay? If we are taking use of, we are going to have, this is the value above the highest points. Okay? 60 minus 0, 100 minus 0 will be equal to, this is the value we are looking for, minus x naught. Our x naught is this, which is 3. This is 18. 3 again. Okay? This is 60 over 100 will be equal to, this is theta minus 3. This is 15. Cross multiply. 100 into theta minus 3. 60. 15. This is 100 theta minus 300 will be equal to 60 times 15 will give us 900. Can you see that? So that 100 theta will be equal to 900 plus 300. Can you see that? 100 theta will now be equal to, this will be 1200. So that 1200 divided by 100. And what you are having there for theta will be equal to 12 in centimeter. So this is going to be the value that will correspond to 60 degrees. another new topic, and that is gas law. Under this topic, the candidate should be able to interpret the gas laws. Then at the same time, they should be able to use expression of these laws, that is gas law, to solve numerical problem. So briefly, we are going to consider the following. We shall consider the following laws. That's Boyle's law. For Boyle's law, it states that for a fixed mass of gas at constant temperature, the pressure P is inversely proportional to the following, which means P will be equal to K over V, so that K will be equal to PV, where our K is our temperature, which is a constant. From this relation, which we can have, P1, V1 is equal to P2, V2. And this is a relation for a Boyle's law. P1, V1, our P1 is the initial volume.